Hi everyone, welcome. This is Desi Vijay. I'm a NorthSouth National Team member and a coordinator for these webinars. Glad to see you all here today. As all of you know, our registrations for this year's in-person regional contests are already open. The contests start happening in April during 3 weekends through May middle. This year it's in-person contest after being online for the last couple of years. Just like we did last few years, we have been bringing in a few of our past winners and various subject matters to talk to you, the younger peers, about their experience, provide some tips, and answer the questions. We call this as Meet the Pro type webinar session. Today we have 4 enthusiastic youngsters with me here, ready to talk to you about math, the most ever popular contest that attracts the most registrations in this contest. These youngsters have been very active with our mathematics team also, and have participated in many of the live problem solving sessions earlier. They will also make a brief presentation of one of the math subjects. Thank you for attending, and thank you for all your support. Without further ado, we would like to start the session. If you want to listen to any of the previous webinars, we have now an option at YouTube. You can subscribe to NorthSouth YouTube channel and then watch and enjoy our past webinars. And you can save the playlist too, and then any future webinars it can come in. If you don't find any of them in there, you can also send us email at webinars@northsouth.org about any specific session, and I'll send you the link. And let me say we have 4 very outstanding math specialists are here who have been very active in this math logic and program, and then they are here to make a presentation. First, I'm going to go through the, first we will go through the contest information. We are going to invite Ritik Gumbu to talk to you about his the information and also his presentation. Ritik is a 9th grader from WWPI school in North New Jersey, who is interested in math, computer science, and physics. At 2022 Math Counts Nationals, he helped his team to win gold medal. He's a 3-time AIME qualifier, even during 7th, 8th, and 9th grades. He is aiming for a USA JMO qualification this year. In 2022 Science Bowl, he helped his team to go to the national, and he won 5th place overall. He has won several medals in science Olympiad invitations and regionals. He likes programming challenges and then participates in computing Olympiads as well. He had created several websites and worked on a machine learning program that analyzes, calculates, and the diabetic level. In his free time, he likes to play sports, games, and creating games. He is going to talk to you about recursions and inductions after the contest info. Take it away, right, Ritik?
All right, so this is the contest info. As you know, there are 3 levels in Math B. There is Math B level 1, which is for the elementary school grades of 1, 2, and 3. There's Math B level 2, MB2, with grades 4 and 5. And finally, the last level, which is also the hardest level, where there's going to be more challenging information and problems, is going to be for grades 6, 7, and 8. The Math Bs from MB1 through MB3 are all held in 2 phases, phases 1 and phase 2. For both of these phases, you must bring your own pencils and sharpeners, and for both of these phases, parents are not allowed to communicate or guide contestants throughout them. Phase 1 is going to be the longer section, where it's going to be 25 questions and 35 minutes to answer these 25 questions. So they're going to be sort of longer problems that take more time to answer, Whereas compared to phase 2, there's going to be 20 questions, 20 multiple choice questions, and the time you have to solve these questions is 15 minutes. So it's going to be more fast paced, and you have to be able to solve them under a shorter amount of time. All contestants participate in phases 1 and 2. There is no like elimination system for phase 1. It's both contestants take phase 1 and 2, and the scores are added up. Calculators are not allowed for these phases. And also, there's no step shown. It's just a final answer, meaning that there will be no partial credit for any step shown or any work shown. There's also no negative points for incorrect guessing. So I recommend that if you don't know the answer to a question, you just guess it, because there's a small chance that you could get it correct rather than get the guaranteed 0 points if you leave it blank. Invitational to the national finals is based not on rankings of the regionals. So let's say you get top 3 in a certain regional, and another person gets like top 20 in another certain regional. It's based on score. So if those 2 people got the same score and they both qualify for nationals, then both people go, even though one placed 3rd and one placed 20th in their regionals. So yeah, and invitational to the national finals is basically based on the score of both phase 1 and phase 2 combined. And tiebreaker rules will be specified in the website for further details. These are the links, like the math info will be over there, like the rules, the syllabus, the presentation, preparation, and everything. The regional contest info will be on the NSF website, and there will be the registration will also be on the NSF website as well. I highly recommend you should register for NSF if you haven't already. And yeah.
And also we'll send the document to you tomorrow, so you can activate those, use those links for you don't have to note down now. Okay, so here we have Ritik talk about his topic.
All right, so I'm going to be presenting recursion and induction today. Okay, so what is recursion? Recursion is the act of repeating a process over and over again in a certain sequence. A famous example of this is the Fibonacci sequence, where you take 2 previous terms, add them together to form the next term. For example, the Fibonacci sequence goes like 1, 1, 2, basically meaning that the 2 is produced from the 1 and 1 added from the previous 2 terms. And that's recursion. You repeat the same process over and over again. Induction is where you prove a certain pattern that you notice in a sequence. And to basically prove induction, you have to start by proving the base case, basically the first small example of that pattern. And then if you want to prove it true for any number n, by assuming it for n and then proving it true for n plus 1. So that basically, if you prove the base case, you can prove it true for any number past that, because you're proving it for n plus 1. So you can just add 1 to 1. You proved it correct for 2, you proved it correct for 3, and then so on and so on. So you proved it true for all numbers. Yeah. Let's look at a small example with induction. Induction is very important when you notice a pattern in a sequence. So there's a very important and famous example of induction, and it can be shown with the sum of the first n positive whole numbers. So let's say you wanted to, prove this pattern you see here: 1 plus 2 plus 3 dot 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 plus n equals n times n plus 1 over 2. First, as we saw before, for induction, you would prove the base case. The base case is the smallest number, n equals 1. And if you plug in n equals 1 into the sequence, you just get 1 equals 1, which is true. So you prove the base case. Then you want to assume that 1 plus 2 plus 3 dot 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 to n is equal to n times n plus 1 is true. You want to prove that you want to assume that this pattern is true. And basically we're trying to prove it true for n plus 1. So we're assuming it for n, proving it true for n plus 1. So to prove it true for n plus 1, we add n plus 1 to both sides, because then we get 1 plus 2 plus 3 dot 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 plus n plus 1 equals n times n plus 1 over 2 plus n plus 1. And if we expand the right hand side, we get that that's equal to n squared plus 3n plus 2 all over 2, which is n plus 1 times n plus 2 all over 2. And if you plug in n plus 1 into the original pattern, you get that it would be n plus 1 times n plus 2 over 2. So therefore, this n plus 1 satisfies our pattern. So we are done as the pattern has been proved true by induction. Because if you prove that n plus 1 is true, you're basing off the fact that n is true. So 2 is true because 1 works, 3 is true because 2 works, 4 is true because 3 works, and dot dot dot. So this pattern applies for all numbers. Okay, now let's move on to recursion. Recursion is basically, as said before, a repeating formula that bases off previous terms to help find the next term. We looked at the Fibonacci sequence where it's 1, 1, 2, dot, dot, dot. And the notation for this would be f of n equals f of n minus 1 plus f of n minus 2, where f of n is the nth term in the sequence. And basically, recursion can be found in unexpected situations. You will see that in the next slide where we have a few practice problems that I will be explaining. Okay, here are some fun examples. Due to time constraints, I won't explain the third problem, but I'll explain the first two. So Fred wants to climb a 10-step staircase. He can climb either 1 or 2 steps at a time. How many ways can he climb the staircase? This is a famous example of recursion, and basically you work backwards. You see that you have a 10-step staircase, and you can climb either 1 or 2 at a time. So if we look at the end jump, basically like the last jump that Fred does, he either had to be at the 8th step or the 9th step, because then Fred can move the 2 steps at one time, so he had to be at the 8th step, or he can move 1 step at one time, so he had to be at the 9th step. So as using our recursion from before, this would mean that f of 10 equals f of 9 plus f of 8. And this basically becomes a recursive sequence like before, because it's just f of n equals f of n minus 1 plus f of n minus 2, which is the Fibonacci sequence. So if you use the Fibonacci sequence to calculate it up to f of 10, you would get that the answer is f of 10, which is 89. So the answer is 89 ways to climb the staircase. Problem 2. Problem 2 is you can use either induction or recursion for this one. But I would recommend using recursion for this one because it's easier, but you can try finding the induction solution by yourself later. In the sequence 2001, 2002, 2003, dot, 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 each term is found by subtracting the previous term from the sum of the 2 terms that precede that term. So basically, you have a plus b minus c. So in this case, it would be 2001 plus 2002 minus 2003 equals 2000. This is similar to our Fibonacci sequence as before, because you're doing something with the previous terms, aka meaning it's recursion. So you want to find the 2004th term in this sequence. So the best way to find the 2004th term in this sequence is basically to like calculate a few terms more, like a of 5 equals 2005, a of 6 equals 1998 if you calculate it. And basically you get a recursive pattern. A of 2k plus 1 equals 2001 plus 2k, and a of 2k is equal to 2004 minus 2k. So basically, you get these patterns that appear because of recursion, and using a recursive sequence, we can also sort of prove this. The formula we are given is that a of n equals a of n minus 3 plus a of n minus 2 minus a of n minus 1, right? And if we use n as the smallest term, basically then we just get like a of n plus a of n plus 1 minus a of n plus 2 equals a of n plus 3, which is basically what our sequence is by using our formula over here, since the third term is found by subtracting the previous term from the sum of the 2 terms that precede it. Correct? So basically we can rearrange this sequence to get a of n plus a of n plus 1 equals a of n plus 2 plus a of n plus 3. So basically, we can get that a1 plus a2 equals a3 plus a4 equals a5 plus a6, dot, 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 where a of n is like the nth term in the sequence, right? So we can see from these problem values that a of 3 is 2003 and a of 1 is 2001, as given in the problem. So that means a of 3 is equal to a of 1 plus 2. So that means since we have the formula a of n plus a of n plus 1 equals a of n plus 2 plus a of n plus 3, we have that a of 1 plus a of 2 equals a of 3 plus a of 4. And basically we can get a recursive pattern, meaning that a of 2004 is equal to a of 2002 minus 2 equals a of 2000 minus 4 dot 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 to a of 2 minus 2002. So a of 2004 becomes a of 2 minus 2002, which is just 0. Just by using a recursive function, we can shorten it down and basically use it to calculate what we want. So the answer is 0. And the third one is left as a example to the people watching. You have to use induction to solve it. And I just wanted to say a little bit about my NorthSouth journey. For all of you who haven't signed up for NorthSouth yet, I highly recommend you should, because I got into it because of a friend, and it was super helpful to me, as like it helped me grow and develop as a person and enhance my abilities in science, math, and like more subjects. It helped me learn new techniques and strategies, and it basically motivated me to become better in all areas and work towards a goal of, going to nationals and doing well. And it was a very fun experience every year that I went to NSF, and I enjoyed everything about it, including like the competition, the people, everything. The in contest, like the contest in person was very fun, and I found that I learned a lot from it. So all of you should go, and all of you that are deciding to sign up should give it a shot, give it a try your best and have fun. Yeah, I think it will be a great experience for everyone.
Thank you, Ritik. And as you know, Ritik also came to us as a science pro a couple of weeks ago. So thank you, Ritik, for your time and efforts. Then next we move on to Trisha Kalpati. She's a junior in high school, and she's a 4-time AIME qualifier, highest score of 8, and has attended Math Counts and Science Bowl nationals and competed AP Calculus BC in 8th grade itself. She participates in STEM clubs at school, including Science Bowl and Anatomy Lab. She's a reviewer of NorthSouth Mathemagic team and conducted several live problem-solving sessions for AMC 8, 10, AMIE, etc. She was a coach for AP Physics 1 and in the summer of 22, and is also a coach for AMA class. She is passionate about Bharatanatyam and completed her Arangetram in June 22. Trisha aspires to be a neurosurgeon in the future and conducts neuroscience research at our local university. We are really proud to have her with us here, and she wanted to talk about sequence and series, and probably she's following up the same pattern. Trisha, take it away.
Thank you, Uncle. Thank you for this opportunity. So yes, I am going to be talking about sequences and series, and then I'll talk about my story, just how Rithik did. So sequences and series. So a sequence is basically an ordered list of numbers, and series is the sum of the elements of the sequence. People often get these mixed up, but having the definition separate is important. So the series is the sum of the sequence. Next slide, please. So there are numerous types of series. I've just put 3 of them here that will probably come up in the competitions that you see, especially for level 3 people. And they are arithmetic sequences, arithmetic series, geometric series, and telescoping series. There's also like recursive sequences that Rithik just talked about. There's numerous types of them that we just can't cover everything, but here I'm going to be talking about arithmetic and geometric series. So an arithmetic sequence is a sequence of numbers in which each term is given by adding a fixed value to the previous term. So for example, like 1, 3, 5, 7, 9. You're adding 2 each time, and the difference, the 2, is called the common difference. And we usually label that with a D. And it doesn't have to start with 1, it can start with any like number, it can be a decimal. It just has to have a common difference between each of the terms. So in the image I have here, I have a sample of a sequence in just algebraic terms like A is the first term in the sequence. Second term will be A plus D. Third term will be A plus 2D. Fourth term will be A plus 3D. So to calculate the nth term, each time we're adding a D to the sequence, right? So we have to multiply by however many Ds we add. And as you can see, the second term, you're only adding 1D. The third term, you're adding 2Ds. So you're always you're adding the term number minus 1. So you do n minus 1 times D, and then you obviously add the first term. So that's how you find the nth term. This is a very common formula that you see. And then to find the series or the sum of the sequence of the first n terms, there's two ways you can do it. They're just build off of one another. So the first one is if you're given the first term, the number of terms in the sequence you have, and the common difference. So you just plug it in, you divide by 2 with the number of terms, and then you multiply by 2a plus n minus 1 times d. But if you notice, like the second term is a plus an, or the last term in the sequence, a sub n, sorry. If you notice, the thing in the parentheses or the brackets in the first equation that they give for sum, that's 2a plus n minus 1 times d, right? But if you split the 2a into just a plus a, you're given a plus a plus n minus 1 times d.
Sorry.
Uncle, could you go to the last slide?
Yeah, sorry. It just got stuck in there. Okay. Sorry. Oh, no.
No problem. I think it's down. It's down.
Oh, okay.
Those are the thick slides. Slide
yeah, there it is. Right?
Yes.
Okay, sorry.
If you just press slideshow, yes. Okay. So let it load. Okay, yeah. So the first, in the sum of the first n terms, the first equation is 2a plus n minus 1 times d. But if we split the 2a, we get a plus n minus 1 times d. But you can see that the nth term is just a plus n minus 1 times d, right? So we're just subbing in a sub n for a plus n minus 1 times d. So that's why we get a plus a sub n. So if we're given the first term and the last term, the only thing we have to do is multiply the number of terms divided by 2 times the sum of the first term and the last term. And the proof of this is very simple. You can just search it up. It's very easy to do. Next slide. Cool. Okay, so this was on the AMC 12A, 2005, I believe, or 2012, somewhere around then. But this question is, let A, B, C, D, and E be 5 consecutive terms in an arithmetic sequence, and suppose that A plus B plus C plus D plus E equals 30. Which of A, B, C, D, or E can be found? So given this question, it seems very arbitrary. Like, we're not given any terms. The only number we're given is the sum. But what's could you just click on the slide, Uncle? Yeah. So what we can use to our advantage is our knowledge about arithmetic sequences and how they're formed based on like adding and subtracting common differences, right? So each term is adding a common difference. So if we set C equal to C, D is equal to C plus, let's define F as the common difference as shown in this solution. D is equal to C plus F. B is equal to C minus F, because C minus F plus F is just C. And then A is equal to C minus 2F, and E equals C plus 2F. So you can see that A, B, D, and E all cancel out because they're just the complement of each other with the plus or minus F. So we can even find the term for C, because if we add it all, 5C equals 30 and C equals 6. So, but we don't know what F is, so no matter what F is, C is going to be equal to 6, and we can always find out the value of C. Next slide. Okay, so now that we've looked at arithmetic sequences, there's a lot more to talk about in that, but I encourage you to just look that up. we can move on to geometric sequences and series. So a geometric sequence is a sequence of numbers in which each term is a fixed multiple of the previous term. So like I gave an example for the last arithmetic, let's say 2, 4, 8, 16. This time they're being multiplied by the same number. So in this case, it's being multiplied by 2. And this is known as a fixed ratio, common ratio, which is usually denoted as R for ratio. So the sequence, as you can see there, is like A, and then the second term is A times R, the third term is A times R squared. And in similar fashion to the arithmetic sequences, the nth term of the geometric sequence is A times R to the n minus 1. N minus 1 being, since the first term is R to the 0, A times R to the 0. So the one thing is that in the difference between arithmetic and geometric is that there's two different equations we need to know to find the sum. Like with arithmetic sequences, we saw that it was just built off of one another, but these are a little bit more different because a geometric sequence, if we can find the sum of an infinite geometric sequence or a geometric sequence that just goes on if the ratio is less than 1, because all the terms are decreasing and will eventually lead to 0. So there is an equation for that, which is A divided by 1 minus R, first sequence over 1 minus the common ratio. But if we want to find the sum of a finite geometric sequence, we can't do that because sometimes the ratio is greater than 1, like the example I showed you, and we can't find the sum of an infinite geometric sequence with a ratio. Well, the infinite geometric sequence with a ratio greater than 1 is just infinity, the sum of that. But to find the sum of a finite geometric sequence is A times 1 minus R to the n over 1 minus R, or just multiplying the top and bottom by -1, we get the second equation. So there are two different types of sums for a geometric sequence. Next slide. So here's an example with a ratio of less than 1. So we have find the value of 1/3 plus 1/9 plus 1/27, etc., etc. So the first term is 1/3, and our common ratio is R. And our common ratio R is also 1/3. And since that is less than 1, and I've asked you guys to find the value of just the infinite geometric sequence, the sum of that, we do A1, which is 1/3 over 1 minus R. R is 1/3, so we do 1/3 over 1 minus 1/3, which is just 1/3 over 2/3, which is then just equal to 1/2. And that's how we do questions like this. Obviously, these questions, again, will get increasingly and progressively harder as you move on down the levels, but this is just like an introduction to that. And I definitely encourage you to look at other problems such as in the AMCs and in math counts questions to look at the different like types of problems that involve these sequences. So I don't have a slide, but I'll just talk about my experience with math and NorthSouth. So I actually was introduced to math competitions through NorthSouth Foundation in first grade. That was 10 years ago. I was able to go to the national finals for NorthSouth Foundation in first grade, and that's where I really got exposed to the environment of a math competition. And I really just fell in love with the competitive environment and the friends I made there. And that's what provoked me to continue with math. And I just have attended, I think I've attended national finals for NorthSouth every year since then, including in 9th and 10th grade through Brain Bee, still getting involved in those high school competitions just because of how much I love it. And I love to like give back to the community, which is why I joined with the Math Magic team and the AP class initiative and Amy initiative. It's just a really fun way to tell like the students how much I like math and how much I do, and how NorthSouth has affected me. And definitely in high school, as Uncle said, I do want to be a neurosurgeon. My focus has kind of shifted to the biological and medical sciences, but I still love to do a math problem here or there, which is what I think is the most important. Like that's what I've taken, is just a love for math that was kind of instilled by NorthSouth. So I definitely encourage everyone to do the regional competitions because you get a sense of what a competition is like, and I think everyone will really enjoy it. Yeah, thank you.
Thank you, Trisha. Your enthusiasm in math shows really, so even though you're going into the medical area. Next, we move on to the younger Kalpati, Avisha. She is a freshman in the high school. She's completed AP Calculus BC in 8th grade itself, and also competes in numerous math competitions, science fairs, brain bee competitions. She's also a reviewer for the NorthSouth Mathemagic team, and is also coach for AP Calculus BC class. Havisha also performs neuroscience research at her local university. Outside academic, she completed her Bharatanatyam Arangetram with a sister in June 22 and gives local vocal performances. So she's a singer too. Welcome to the panel, and then Avisha will be talking about probability, little away from all these algebraic problems.
Okay, hi everyone, I'm Havisha. Like Uncle mentioned, I'll be talking about probability. Can you go to the next slide, Uncle? Thank you. So probability is basically the likeliness or chance of something occurring. This can be in proportions, fractions, percentages. When it's in proportions or fractions, they're generally between 0 and 1. And probability is a lot more than just knowing the likeliness, which I'll explain in more slides. So, Uncle, can you go to the next slide?
This one?
So, yeah. So this is a very basic example of probability. There is a 30% chance of rain tomorrow, and there is a 60% chance that I will wear a blue shirt tomorrow. What is the probability that it rains tomorrow, but I do not wear a blue shirt? This problem, I'm pretty sure, has shown up in like every single elementary level competition math test. It just really tests whether you know the basics of probability. So, Uncle, can you click one more time? Thank you. So basically, we want to know first the probability that it rains, but I don't wear a blue shirt. And when we see the word and, you should automatically think multiplication because you want to know the probability of this occurring and that occurring. So you need to multiply them together. Whereas if you see the word or, then you'll end up adding them together because you want this or that. So the probability that it rains, as we know, is 30 over 100 or 0.3. And then the probability that I don't wear a blue shirt is 40 over 100 or 0.4. So multiplying those together, we get 0.12 or 12%. So there's a 12% probability that it rains and I don't wear a blue shirt. Next slide, please. So this is another concept that's very common in probability. I'm pretty sure all of you guys know this. This is called Pascal's triangle. And this is also used to find the coefficients in polynomials, but it's also very commonly used in probability. Can you go to the next slide, please? And so the way that we get these numbers is we use the combinations function. So for example, if you have 4 items and you want to know how many different ways they can be arranged, if you have 4 different items and one of them is one thing, 3 of them are the same other thing, for example, then you can see how many ways are there to arrange them. So for example, if they're all the same item, then there's one way to arrange it. That's 4 choose 0. Or if there's 3 of one item and then 1 of another item, then there's 4 choose 1, 4 ways to arrange it. So this is how we end up forming the Pascal's triangle, and it just keeps on going. But the most common rows go up to row 6 or 7. Next slide, please. So this is another problem. It's from the AMC8, I think, one of the earlier AMC8s. So this problem reads, 4 children were born at City Hospital yesterday. Assume each child is equally likely to be a boy or a girl. Which of the following outcomes is most likely? And so we have a bunch of different outcomes here, and we want to see which one is most likely of occurring. Can you click one more time, Uncle? Sorry, I have so many animations. So here's an example of the Pascal's triangle. We know that there are 4 children, so we want to go up to the 4th row. And then at the bottom, as you can see, I've written out like how many different combinations there are for each grouping of boys and girls. So if you have 0 boys and 4 girls, then there's only one way to get that. Same thing if you have 4 boys and 0 girls. And then you do the same thing for 1 boy, 3 girls, 2 boys, 2 girls, 3 boys, 1 girl, and it just goes on like that. And then something else to know is the total number of combinations that there are is always 2 to the power of n. So that'll most likely be your denominator. Can you click one more time, Uncle? Okay, so first we want to know the probability that all 4 of them are boys. And there's only one chance, like I said, of that happening. Then if there are 2 girls and 2 boys, then as you can see, there's a 6 out of 16 chance. I skipped over 4 girls, but that's also 1 out of 16. And then also 3 of one gender and 1 of the other. So that means we could have 3 boys and 1 girl, or 1 boy and 3 girls. And so the way that is, it's 4 over 16 plus 4 over 16, which is 8 over 16, which is also 1/2. So as you can see, it's pretty obvious here that 1/2 is the largest out of all of them. So it's most likely to get 3 kids of one gender and 1 of the other. So that's another very basic example of probability. I stuck to more of the basics for this. But also there are so many real world applications. So Uncle, next slide, please. So I'm currently taking an AP statistics course, and this is where I was like more introduced to the not competition math aspect, but I just wanted to introduce these. So probability can also be used for sampling. So if you want, for example, to find out something about the whole population, but you don't have the budget or the time for that, you can take small samples and you can see whether that represents the population using proportions for probability. And then also we can use p-values. This is something very commonly used. And this is the likelihood of one thing occurring considering the other is true. And I actually have an example of this. So for example, in 1992, there was like a 76% proportion of babies were sleeping on their stomachs, and then doctors were saying that's not healthy, and so then they resampled in 1996 to see if the proportion of babies sleeping on their stomach had decreased. So the way that you would use the p-value is you would first assume that it did not decrease, and then you would see it was 76% in 1992 and then like 20% in 1996. How likely is it to occur that it was 20% in 1996, given that there was no difference in the proportion of babies that were sleeping on their stomachs? So this is what p-values are used for. And then this probability is also used for expecting outcomes, predicting trends. For example, we have an election coming up soon. People use probability to, like, for example, say what proportion of people think this person is going to win. And then also, like Uncle said, I did a computational project, and that's where I was like introduced to a lot of the statistical aspect of probability. So statistical analyses, what is the probability that a gene is expressed, all that kind of stuff. So those were some of the basics of probability. The problems definitely get a lot harder once you enter the more advanced stages of competition math, but I hope that you all learned something from this, that probability is not just finding out what proportion of babies could be a boy or a girl. And there's so much more to it. So then I also wanted to talk about my North-South experience. I don't have a slide either, but it's pretty similar to my sisters. Everyone thinks we're like twins. We do basically the same stuff. I also want to do neuroscience when I grow up. But North-South, I also started when I was in kindergarten, and that was like the first time that I was also introduced to competition math. But one thing I will say is I've done a lot of different competitions, but North-South was definitely the one where people were the most like energetic. It was not as stressful because everyone was just really happy to be there. So people weren't uptight. And then so taking the like experience from North-South, in January, actually, me and my sister, we created a competition for Pittsburgh elementary and middle school kids, and we had like overwhelming responses. And I can like say for sure that that would not have happened without our experience with NorthSouth and like teaching the students for AP Calc, reviewing and writing questions for the competitions. It's been really great. So I highly recommend everyone to sign up and join. Thank you for your time.
Thank you, Avisha. Yeah, please listen to Avisha. Math, it really rocks. Next, we will welcome Vivek Allurpalli. He's also appeared in many of our sessions before. He is currently a senior in high school. He's a 5-time AIME qualifier and completed AP Calculus BC in the 10th grade. He is currently taking course in differential equations. In recent years, he has helped conduct AMC live problem solving sessions and has written problems for the NorthSouth Mathemagic team. And currently, he is a captain of the school's math team, as well as the senior petrol reader for his Boy Scout troops. Great. So he wants to talk about geometry in his presentation today.
Go to the next slide.
Yeah.
Yeah, so hi everyone. The main topic I'll be kind of covering is in geometry. And of course, there's a lot in geometry. So I'll really be focusing on geometry relating to triangles and circles for this presentation. So here are some geometry terms that we can go over first. So on the left, we have what's called the in circle. So we have triangle ABC here. And what the in circle of this triangle is basically the unique circle that's internally tangent to the 3 sides of this triangle. So we can see here that this circle is touching and is tangent to AC, BC, and AB. And the radius of this in circle is called the in radius. Now on the right side, we have a different type of circle called the circumcircle. And this circle, it's different than the in circle. This circle is containing the points A, B, C on the circle. So it's actually bigger than the triangle. And the radius of this circle is called the circumradius. Next slide. So why was that last slide kind of important? So here are some formulas that you can use to find the area of a triangle other than just 1/2 base height, obviously. And 2 of these use the in radius and the circumradius in those formulas. Now these are 3 very important formulas, especially as I know a lot of you are interested in competition math, like all of us are and were. So I'll go one by one with these and kind of explain them. So the first is called A equals RS. Now A is just the area of the triangle. And what RS means, so R is just the length of the radius of the in circle. And S is what's called the semi-perimeter of the triangle, which is the perimeter divided by 2. And what you can do is you can multiply these and you actually do get the area of a triangle. And we'll use that in the next slide, but we're not there yet. The second formula is called Heron's formula. And this shows that the area of a triangle is the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. And this Heron's formula is very useful when you're trying to find the area of a triangle, but you only just have the sides of the triangle, because that's all you need to find this area. And the third is the area of the triangle is ABC, and ABC are the side lengths of the triangle. So you multiply those 3 side lengths and divide it by 4 times the circumradius. So these are all 3 formulas. They do show up. A lot of you, I think, are going to be doing the AMC's competition soon, whether it's 8 to 10, 12. These do come up, maybe not in the AMC 8 as much, but definitely in the 10 and 12. These are important ones to know. So yeah, next slide, please. So here's a practice problem relating with one of those 3 formulas in that last slide. So we have a triangle here with side lengths 15, 15, and 24 with an in circle inside it. So if we know that the height of this triangle is 9, which we can know with the Pythagorean theorem, what is the in radius r? So we can use the formula A equals RS to find this. So there's a transition, Daisy Uncle. So because we know that the area of the triangle is, of course, 1/2 times base times height, we can use this bottom base here of 24 and the height of 9 to find the area of the triangle, which is 1/2 times 24 times 9, which is 108. Next transition, Uncle. So we can use the fact that A equals RS here and try to find the semi-perimeter of the triangle. So we know the perimeter of the triangle is 15 plus 15 plus 24, which is 54. So the semi-perimeter is 27. Next one. So because A equals RS and A is 108 and S is 27, as we know, we can actually solve for R using that equation. So next one, Uncle. So here's the work right here. A equals RS, so 108 is 27 times R. So R is 108 divided by 27, and R is 4. So you know that the in radius of the triangle here is just 4. So it's one way. This is, I think this was a spin-off of an AMC 10 or 12 problem. But you can see kind of here how you can use these formulas with other formulas like here 1/2 base height to get an answer. Next slide, please. So here's another formula in geometry that I found very useful when I was doing competitions, and it's called the power of a point formula. And this one's pretty interesting. So let's look at this left circle for a second. So you see that point where the two lines intersect, the two line segments intersect in that circle. So what's interesting about this is that when you have a point inside a circle that's dividing a line, two lines, the product of the two line segments here, where you have AB and CD, the product of those line segments is always the same. It's always the same. And it's for any point inside a circle and any two pairs of line segments that you have, the product of those will always be the same. So here, like it says, AB equals CD. Then the other application of power of a point is when the point is outside of the circle, where if you have, again here, lines going from through the circle and through the point, the distance from the point K, here it's K, to the other 2 points that the line intersects in the circle, that product is also always equal. So here, Ki times Kj is still equal to Kl times Km. And it also applies when the line is tangent to the circle, which means both points that it intersects the circle with are actually the same point. So here, Kh squared is still equal to the other two products. And this I found very useful. It's when a lot of you do math counts, AMC 10 again, it's still very useful. And even on the AMC 12, even as high up as the AME, it'll still show up in some way or another. So it's very useful, both. Next slide, please. So here's a practice problem. I didn't end transitions, but you can see here that you can use power of a point to solve for this value of x that you normally don't know. So you have here, A is the point inside the circle, and you know that AB is 1 and AC is 4. Then AD is x, then AE is 6. So with power of a point, you know that AB times AC is equal to AD times AE. So you know that AB times AC is just 4, and AD times AE is just 6 times x. So you know that 4 is 6 times x. You solve for x, and then you get x is just 2 over 3. The next slide. So it's the last thing I want to say about geometry is just that the best way to get better is just by doing lots and lots of problems. You can know as many formulas and theorems as you want, like I said, but the best way to really get them ingrained in your mind and build that intuition is just by doing practice problems. And that's kind of where competitions, especially like NSF, are very important for me. Like Thrisha and Havisha, I did math competitions from a very young age. I started NSF when I was in kindergarten, and then I've been involved with that and other competitions like AMC and Math Counts ever since then. And I found that those experiences have been like very important in my life. But I'd recommend not looking at those competitions as just a test and really like an experiences. because kind of the people you meet, the things you learn are, you know, just as important as any award, and arguably more important than any award, you know, you might win. And even though I'm graduating high school in a few months, kind of the people I've met are things that, like, you know, friendship that'll last a lifetime. And now my NSF involvement, like Daisy Uncle said, I spoke at some past problem solving seminars. I did some problem writing for the Math and Magic team a few years ago. And yeah, I've enjoyed that, my experiences here volunteering just as much as I've had competing with NSF. And, you know, Rithik, Thrisha, Havisha, Daisy Uncle, Vinay Uncle is there too. They're all, you know, everyone else on the NSF team, they're all great people who I've got to work with. So I'd encourage kind of anyone else who's enjoyed their time at NSF to also consider volunteering at some point. You know, there's many opportunities that you can help make a difference. And it's people like you that help make NorthSouth a success every year. So that's all I have to say. Thank you for listening.
Thank you, everyone. Yeah, everything went so well. You guys are showed what you guys are made up of. And I really encourage everyone who listened to them to really go through this again tomorrow, and then to grasp all those things, because there are so much of information packed in there in such a brief time. Thank you. And then we will get to the questions. Please keep posting your questions so that we will go as we receive them, and that whatever you this thing you wanted to learn from these people, you can always ask. Okay, so there is one fun fact. Okay, Fibonacci sequence was discovered by Hemachandra, a mathematician from ancient India, centuries before Fibonacci. It was erroneously known as Fibonacci in the West. It should have been called Hemachandra sequence. Good to know. Can you recommend some books to introduce these concepts to the kids? Who wants to take that?
I guess.
No,
Never mind.
Yeah, go ahead, Vivek.
Yeah, so I guess some books that helped me are the Art of Problem Solving books. They have a whole set of textbooks, very useful, and they have it on a whole different levels. They have it starting, I think, from pre-calculus, and I think even earlier now. Then it goes all the way up to different subjects like accounting and probability, geometry, algebra, calculus, and so I used some of those books when I was kind of in middle school and early high school. So I think those are very popular too. So I think those are definitely some useful books that I've had.
Okay. Anybody else?
I'd like to say, along with books, it's also extremely important to be doing past problems, because that'll get you a lot more comfortable with like the feel of competition math. So try doing like all the past AMC 10, AMC 12, maybe even AME problems, and that'll definitely help you a lot.
Thank you. The next one, I think, probably for Trisha. Can you also use subtract as an arithmetic sequence? You talked about addition.
Oh, like subtracting? Yeah, definitely. Say like 5, 3, 1, -1. The common difference is just negative in this case. So you just plug in a negative number for the common difference.
Okay. Then the next one they're asking is, can you please let us know more about this Mathmagic program? We have a first grader too interested in math, and please suggest some math programs for that age.
So the Mathmagic program is like a writing and reviewing initiative. So that's not really for first graders. It's more like us writing problems for the first graders. So programs for first graders definitely at NorthSouth, and just finding any local competitions that are available. Competitions definitely are a lot more abundant in middle and high school. So it's a bit difficult to find them for early on, but there's like Math Olympiad, like the elementary math Olympiads, and a lot of where I used to live had a lot of local competitions. So try to reach out to friends and anyone you think will be interested to see.
Yeah, also like what Trisha said, there's many oftentimes there's many kind of local competitions just held at the middle schools or high schools run by other students older than you that you can kind of take part in. So like for me, there was one called WWPNT. It was just run by the high schoolers in my area. So like things like that you can definitely take advantage of.
Thank you.
Also, the Mathmagic team publishes a newsletter with math facts and interesting things. So if somebody wants to contribute to that, you could also send in like a article or something interesting about math to the team, and then that can be published as well. And if you're interested in volunteering, and if you're a high schooler, if you're interested in volunteering, please send an email to coaching@northsouth.org, and so you can also be part of the Mathmagic team.
Yeah, and then my mom also just brought this up. Where we used to live, even though there were a lot of local competitions, we lived in like a not as mathy place, so we would also have to travel a lot. So look at like the other states and see whether there are other competitions going on there that you could also travel to and see.
Yeah, that's good to know. And Vinay, is there a way they can access Mathemagic team, or is there an email or specifically for that? Or
There is, but I think if you send it to coaching@northsouth.org, depending on their grade level, and then we could route it appropriately.
okay. Thanks. Yeah, that'll help. There is a comment to you, Havisha, that it's worth mentioning that you multiply probabilities only when the events in the question are independent.
Yes, yeah, because if they're dependent, then that could, sorry, I forgot to mention that. Make sure that the events are independent, because if they're dependent, then they'll have an effect on each other. So you would need to compute the probabilities respectively.
I really don't understand the question to Vivek, that how can you apply the in circle outside of the competitions?
What was the question again? Sorry.
It says, how can you apply the in circle outside of the competitions? Or I don't know what competitions he's talking about.
Yeah, so I guess outside of a competition setting, like where would that be useful?
Yeah.
That's a good question. So at least for me, it's really just been useful in a competition setting. I know there's like in high school, you'll probably take some course relating to geometry. And then if you look into, going deeper into geometry, like geometric proofs and so on, PowerPoint can definitely prove very useful in those. But definitely I'd say that its biggest use is in competitions.
Okay. So what level are these math problems you talked about? I don't know, is high school grade level probably?
Yeah, probably. And like, I think some of the questions that me and Trisha and like Havisha did, like previous AMC problems, right? And I feel like while it could be hard, some of the concepts could be grasped by, like, I guess, yeah, like ninth graders, eighth graders, really high school students,
My presentation was a little bit more on the middle school, targeted towards middle schoolers, because that is where you start to learn about arithmetic and geometric series. My question was an AMC question, but it was an earlier AMC 12 question that I feel like would fit into later AMC 8 areas. So definitely you can expand more than what I said in my thing, but those are the basic concepts that I just talked about.
Yeah, same with me as well. I stuck to more of the basic concepts of probability, so I'd recommend to go and just like look at more to that because what I explained was just like the start of it.
Yeah, so like what I was teaching, I kind of targeted more for a middle school level. So like 6th, 7th, 8th maybe. And kind of making that more accessible. The questions I took, one was an AMC 12 question, but I had changed it for like more of a middle school level. And then the other one was just a completely separate question. So really just middle school level.
Thank you. Can you suggest some websites on books for the elementary and middle school kids to get interested in math?
I would say just art of problem solving, and like there's a few other websites like I don't know, Weebly, like they have like a compilation of the past like math counts tests, I would say. Like they have like a full list of like all the states and like chapter rounds. So yeah.
Art of problem solving does have a subset called Beast Academy, which is definitely directed towards elementary students, which is very useful. I actually used it when I was around in like 2nd or 3rd grade. So that would be something I look at. Just art of problem solving in general is really great. I think every competition math kid turns to that at some point in their life. So they just have so many different problems for a wide variety from elementary to like college level math. So it really just has everything.
And then two more books that are more suited for like beginners. There's Singapore math books. They're like based on grade level. And then also there's the primary and challenge math books. Those were also pretty good in my opinion.
Thank you. Yeah. What platform, is there any online platform helps you with the math like Kumon or
One is not really competition math. It's more directed towards school math. Once again, I think AOPS is like the best option that's for competition math and the past practice problems. I'm not really sure of other online platforms.
yeah, like you said, practice, that helps.
Yeah, and NorthSouth also has coaching, usually offered from September. So fall season starts in September, and so it's geared towards math counts. So you can look up the available slots in the coaching website, and we may also have something to offer in summer.
Thank you.
And like I think Trisha and Vivek mentioned, there were also live problem solving seminars that they conducted for AMC 8s and AMC 10s. And last year, we also started the AP series for high schoolers. So AP Calculus and the other subjects as well, AP Physics, Bio, Chemistry.
Thank you, Vinay. What are your recommendations to align math taught at school and the North-South competition math to make it mutually work together?
I think almost virtually like everything you learn in school is useful for competition math because starting, say, math, North-South ends around 8th grade for math. And around that time, you're learning like pre-algebra, which is like slope of the lines, algebra 1, quadratics, all those things that are very useful in like solving a problem. The problem might be framed differently, where you need to know how to break the problem down into like the quadratic equation or like finding a linear equation. But in the end, the school math is what helps you solve it. So I think it's already integrated into competition math.
Yeah, that helps then. How do you guys prepare for the math counts or science bowl competitions or nationals? Is there any insight? Anybody, Ritik?
Wait, can you repeat it again? Sorry.
No, how do you guys prepare for math counts, science bowl, and nationals?
Oh, for math counts, I didn't really. I mean, I sort of just did practice tests. That's literally all I did. Like, I just did practice tests over and over again until I got the topics. And I guess a stroke of luck, I guess, because I got 6th in my regionals, then I got 2nd in my state, and then I went to nationals. So I don't know. You need a bit of luck. And then for science bowl, I would say like find a good team. Find a team that you work well with and has like a good chemistry, like a good team dynamic. Because I think that's the main thing. Because you can't win a round without a good team dynamic. And if your team works well together, then it'll be better than a team that's knows more but doesn't have a good team dynamic. So yeah.
Yeah, and I just want to add to the science bowl aspect. Definitely having a team who trusts you and everything is good. And also, it's important to know science bowl is like a wide variety of subjects. It's like biology, physics, chemistry. They have math, energy. So knowing your strength is the best thing. Like knowing your strength and like really honing in on what you're good at, rather than trying to spread yourself too thin. So you can become an expert in your subject and then find people who are experts in the other subjects, is kind of the best way to do it. And it's really helped out that my team is able to do that.
So like both Ritik and Trisha mentioned, so since it has multiple subjects, so if you know your strengths and then like divide the subjects among yourself and then practice together so that you can gain confidence in each other. So you do your subjects well and then also practice with the rest of the team and get better as a team. That will get success.
Thank you. Is it too late for my kids at 5th grade to introduce Math B? Definitely not, right?
Definitely not.
Yeah, it's really never too
No
late to
age is too like young. I know people who have gotten into competition math in like 8th grade and really flourished and just enjoyed it. Sorry, Vivek, I cut you off.
No, yeah, that's fine. But like what Trisha said, like it just depends on how much practice you do. It doesn't matter like when you start or anything like that. Because I also know people who've started in like 7th, 8th, 9th, even 10th grade, and they still did very well. So as long as you're willing to practice, that's all that matters.
Yeah. There's a question that I'm in MB2, 3 math counts. I attended the coaching classes this year. Will it be enough for me to prepare for the with the coaching material for the contest?
I would say that the material definitely helps the coaching classes, but then also you shouldn't just rely on that. You also need to be doing like practice problems once again on your own to prepare.
I also think you should know your level. It might not be like you probably have to take those practice tests to know exactly like how well you stand, and then you can see where your weaknesses are and just practice those things.
Yeah, I would say set a goal and try to, aim yourself towards it. And yeah, that's pretty much it.
Yeah, thank you. And one more on arithmetic sequence, Trisha. Can you use divisions for arithmetic sequence? Is probably less than 1 or equal to less than 1, right?
Oh, is that geometric? Yeah, you can.
Arithmetic sequence.
Arithmetic sequences are adding or subtracting. You can add a fraction, you can subtract a fraction. It's only multiplication and division is regarding geometric sequences.
Okay, yeah, makes sense. Yeah. No. The next question probably Vinay can answer. Do you provide any preparatory classes for elementary kids for taking the competition?
So there is coaching for MB1 as well, but I mean, so if you go to our website, then you can see the different courses available. So yeah, they can explore those options as well. But what we see is in terms of coaching, we don't actually see it as like, okay, it's for this competition or anything. It's just for learning. And then like when you go through the program, right? So you will have like 10 to 16 weeks of every week. You'll have a 1 to 1.5 hour class, and then it will go over the topics that are related. So that will definitely help improve your concepts. And then like all of the parts then said, for the contest preparation, you would have to go beyond that and then prepare by practicing the problems.
Thank you, Vinay. And there was a request that can you please add the websites and the books to the slide deck? Can one of you do it?
Like all the books that we mentioned in the websites?
Yeah, whatever you suggested, just add it to your slides, and then when I send it tomorrow to them, that will be there. And also,
actually, if you go to NorthSouth.org, right? If one of you can maybe show your screen, the syllabus for each level, and there is different tabs for each contest. So there's rules, there's syllabus, there's preparation, and facts. So in the preparation link and the tab, you can see all the books that are recommended that will help.
Yeah,
so the art of problem solving that Trisha mentioned, and then the Khan Academy, all of these resources are mentioned under preparation tab. I'm on my phone, otherwise I would have shared.
Yeah, I know.
But,
yeah, I'm trying to get in there, just going slow. So that's a good place to go there too. Also, we will try to see when it comes. Okay, now it's coming. So let me know. So you're saying use activities contest,
and then click on Math B, and then if you go there, there'll be like 4 tabs. Like, yeah, if you click on Math B, math. Now on the middle there's a math, right?
Yeah.
Yeah. And then if you click on that, there'll be general info, rules, syllabus, and preparation. Under preparation, there's links for books and resources.
For each level, there are different number of books and all.
Yes.
Yeah, please visit there, and then you can see all those things. And if there is anything different, and now you guys can add it to one of your deck, or at the end of the deck you can add. Okay, so we will be able to do it. So let me go to the questions again.
Wait, can I just say one thing?
Yes, please.
For Math B, for like levels 1, 2, and 3, I would say they're not like, you know, as hard as like the AMCs. I would say they use easier concepts. But like if you really like learn just like basic concepts, I think that's enough for NSF. I think speed is kind of what's important here, because if you can apply like, you know, the topics fast, like the simple topics, I think that's like all you really need for NSF. Whereas for AMC, you need to like know a wider array of topics and be able to do it fast, I would say. But like for NSF, it's not like super hard topics that are put into the competition. That's, yeah.
Thanks, Ritik. The next one is how to participate in math count if the school is not registered with math counts. Is there a way we can participate outside of the school?
I think the best thing to do is, yeah, I don't think you can, but I think you should talk to a teacher who would be willing to sponsor a math counts team, and that's where you should go to. And there's a lot of sources available on the Math Counts website to help you get started if the teacher is just there to be there and you can help out to start the team.
Yep. And that applies for Science Bowl as well. So Ritik's team, they formed the team. The school didn't have a science ball team. So the interested students, once they show their commitment and the parents go and approach one of the teachers, and the teachers, all they would be required is to like sign up for the competition to be a guide. But then the parents can actually be the mentors to host the practices. So if you can show that you're committed, and then like you just need the school to help them sign up, I think that should work. And like Trisha mentioned, there is probably already this kind of discussion available in the Math Counts website, where they will probably give you tips as to how to approach your teacher and have that sign up.
Thank you, Vinay. The next one is, where do I do the practice test? Is there a convenient place they can go to?
Well, on the
online.
Yeah, on the
Okay.
on the website again, I think we have a sample 10 problem the sample problems that they can look at, and also I think when they sign up for the contest, also I think they can probably download that 10 the sample problem set. But I think what I would suggest is that, yeah, if you look at least for MB3 level, right? So you can even like look at AMC8 problems for sample to see what kind of problems.
Also, just towards
go
the
ahead.
level higher than AMC, like AMC 10 and AMC 12, all problems are available on artofproblemsolving.com in the AOPS wiki. So AMC 12, AMY, all of them are available, and solutions are readily available as well.
Okay. There is a comment here that for math counts, you can become a non-school competitor, I believe, with https www.mathcounts.org/program/non-school competitor pre-registration resources. I don't know whether.
Oh, great. Thanks for sharing. We'll take a look at that as well, because a lot of people do ask us this question. So
yeah,
thanks.
it looks, I'll put that in the chat. If you guys interested, you can look at it. Okay. I don't know if it is there, but it is the one. The one is general question again. Great session, but how do you guys manage to be high achievers in multiple areas? So who wants to take it up? Or maybe all of you can take it up. Starting with Trisha.
Okay, I think it's just prioritizing stuff. I still struggle with that, but since I'm interested in a wide array of things, I am willing to put in the time for everything, such as like science pool, neuroscience, math, but also like dance, singing, and like family and stuff like that. So just having like setting time aside for each of the things is really important. And I think it's just your organization skills and being willing to study for this amount of time, as well as keeping up with school, because school gets to be really difficult once you get to high school. But just knowing how to manage your time is the key.
Yeah, that's pretty much what I was gonna say. For me, I sort of do things for fun, you know. I sort of just pick them up, and if they look fun, I kind of, just do it. And for Sciable especially, our school didn't have a team. It was sort of just something that me and a group of friends just made for fun. We didn't actually think we were gonna get far with it, but I mean, we made nationals, and it was sort of like a fun experience, like an unknowing experience, like something that I just didn't expect. Like it was, yeah, like pretty unexpected. And I would say just do things for fun. Like even if it like doesn't work out, like you can see what you like, and like with a first-hand experience of something, you can see if you want to continue it or not. You know, spend effort, and who knows, you might have like an event like this happen where you just like, do well. So yeah.
Yeah, and something I would say is I'm only a freshman and I am taking like a few APs, but school is not really that hectic for me as of now. So I would say until you're like really bombarded with school, you have so much time on your hands. And so that is where like you should really prioritize your time. I did not do too well of a job at first, but I think I'm starting to get the hang of it. And it's like those are the crucial times when you need to figure out like how to use your time effectively so that once school becomes like a big thing on your plate, then you'll like know what you want to do and how to spend your free time.
Yeah. With all the, it's just, if you're trying to be, very good at different areas, it's still just the same thing, just practice. Practicing, doing competitions, doing whatever it is. And also the thing about prioritization, like, no one's perfect at it. No one starts perfect at it. It's all just, you kind of grow into it and then get better along the way. I'm sure that's kind of how it worked for everyone else here too on this panel. So, don't feel like intimidated if you're not perfect at it yet, because you don't need to be.
Thank you, everybody. Thanks to all your efforts and you put into these presentations and being here and your patience with all our questions and answering. And good luck to you all guys in the future, and we'll connect again pretty soon. Regarding audience, thank you very much for tuning in, and I hope you got benefited by talking to these youngsters, and hopefully we'll see you again in many other future webinars. Like I mentioned, we are continuing this theme for one last time 2 weeks from today on March 19th, same time. At that time, we are going to meet our geography pros. So please plan to attend. We look for the announcement from us, and also register and attend, and then we will have a totally different exposure to the geography. And thank you, Vivek, Ritik, and Trisha, and Havisha for making this very entertaining session, very helpful session for everybody. Thanks.
Yeah, thank you
for the opportunity.
Thank you for the opportunity.
Please register for the regionals.
Regionals, please. Yeah, we still have time, and then you can review this video tomorrow, and then get more out of it as we doing it again and again. Like all these people repeatedly said, practice is a key for success.